Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is, as a part of ground improvement techniques, today we are going to understand one more case study, that is stone column for liquefaction mitigation at our industrial plant foundation, Gujarat, India. So this is our case study. So according to ground improvement techniques, till now what we understand, as per the what kind of construction we are doing, what type of construction we require. So according to the type of construction, we are going to undergo the process. So where we are going to construct this thing. So at that particular, what is the type of the soil? What are the desired requirements for getting the construction? So we choose the required technique. This is the process we follow for adopting the ground improvement techniques. So once we understand the ground improvement technique, it depends upon the so many parameters are involved. Those are soil type, required characteristics, requirements, project requirements for getting desired properties, what kind of methodologies we are choosing. These are all the parameters we are going to understand till now. So now for this particular case study, each case study, what we are understanding, what are the challenges we are facing, what kind of solutions we are getting from the all these and what we understand till now. So this is step-by-step procedure we follow for this case study also. In this particular case study, Gujarat, that is the area in India. And what kind of project it is, a industrial plant. So like this, based on this site, what type of construction we are doing on which site. So on that particular site, what kind of soil parameters are there, what kind of desired properties we require. These are the base things we have to consider. Now in Gujarat, we are going to construct industrial plant was planned on site that was prone to liquefaction. That is going in the under. This is the challenge in this particular is the liquefaction. Especially during seismic events. So whenever during the earthquakes. So this phenomena where saturated, loose, granular soils temporarily lose their strength and behave like a liquid when subjected to earthquake, shaking or then sudden loading. So this liquefaction is a phenomena where that is going to saturated or loose whenever the earthquake or whenever the shaking and whenever the seismic waves are attacking that particular area. This is behaving like this. So in that particular, we are going to understand in this significant ground instability potentially leading to the catastrophic failure of structural built on such soils. So to mitigate these kind of risk in those kind of characteristic that soil have. So what kind of technique is helpful for us for constructing in the particular site. So in this particular, we are understanding this is the stone columns who are employed as a ground improvement technique. So here this is the thing as per the requirement. So it is behave at the time of earthquake. Remaining is it okay? So whenever the earthquakes or seismic waves are affecting, it is going to lose its stability, its potentiality. But here, whenever we choose this technique, it reduce those effects. So the technique is stone columns. Like that, we have to understand the challenge. So according to the challenge, we are going to consider the solutions what are there. So as per the solutions, what are the consequences we have to understand, what are the things we are getting, what are the advantages, what are the disadvantages involved in that particular technique, we will discuss in this particular case study. Here, liquefaction potential is the challenge. So according to the site condition, they characterized by the loose, saturated sandy soils with a shallow water table. Here that involves the water table, that it should be shallow, it should be deep, whatever it may be, depends upon the case study to case study, it is going to different. So here the site was characterized by the loose, saturated sandy soils with a shallow water table, making it highly suspected. So here, the highly suspectable liquefaction, the soil layers lacked the necessary cohesion and shear strength to withstand the seismic forces. As per the seismic forces, these soil layers are going to be lacked. So because the necessary cohesion and shear strength is going to withstand, so we require necessary cohesion to that particular soils and also the shear strength. These are the desired properties. These are the desired properties. What we require. These are the desired properties. So the site was characterized by these are the soil type of the soil condition. For that construction, industrial plant, whatever the project, it requires withstand these are the desired properties we want. So here the seismic activity. So here one more thing is involved, that is seismic activity. In that, Gujarat is located in seismic activity region, increasing the likelihood of an earthquake triggering liquefaction. So the presence of significant industrial plant with heavy structures added to the complexity of ensuring the stability such conditions. Here it is in seismic activities and the earthquake triggering liquefaction is there. In the presence that particular significance, the construction is highly difficult. That too, industrial plant means it has heavy loads. It is a heavy structure. For adding this heavy complexity in this particular case study, we have to ensure the stability under such these conditions. This is a challenge as a civil engineer how we are rectifying. So as per what we understand from the geotechnical engineering and also the ground improvement techniques, using our structures knowledge, according to that, for sustaining these heavy structure in these particular soil condition, so we have to choose the desired ground improvement technique. So that is nothing but the stone column. Here we prepare for the stone column. Here we consider the technique, ground improvement technique, which was we choose. Now, what are the foundation requirements? So here, according to the what is the potential, now move on to the foundation requirements. Here, load bearing capacity and settlement risk are the parameters which we have to understand. Because the industrial plant is a heavy structure, and also once the seismic waves are attacked, the soil conditions are going to be changed, the soil properties are going to change, it is going to affect itself only. So that's why we have to understand this load bearing capacity. So the industrial plant required a foundation cable of supporting heavy machinery, storage tanks and other critical infrastructure, because it is an industrial plant. It means it is a heavy structure. So in this foundation cable of supporting heavy machinery, storage tanks and their critical infrastructure, the existing soil conditions were inadequate to provide the necessary load bearing capacity. So these existing, what are the soil conditions? Were inadequate. So to provide the necessary loading capacity. For this we required some technique, we required the ground improvement technique for getting the adequate to provide the necessary loading capacity of the industrial plant. And also it involves the settlement risk also. So here the differential settlement risk. There was a risk of differential settlement if some areas of the site liquefied while others remained stable. And this could lead to uneven settlement of the plant's foundation, causing structural damage. So here there was the differential settlement if some areas of the liquid while others remained stable. So it is different scenario. It depends upon the waves and the soil conditions. So whenever we consider complete area, even though some areas may react differently because of the soil condition. So for that, uneven settlement may cause for these foundations, they may causing the structural damage also. Why? Because throughout the soil condition, throughout the site, the soil conditions may not be same. Some areas of the site liquefied with other remaining may be safe, stable. So it depends. Now, this solution is the stone columns. Stone columns is the solution for this technique. So what we understand, so whenever the place is there, based on the soil conditions, so we are facing the what kind of geotechnical challenges, what are the various parameters involved in that particular challenges. Now we choose the solution that is nothing but the stone column for the liquefaction mitigation. Liquefaction mitigation. Now what is meant by stone column, how we are going to install, these are the things we have to understand before going to the case study. Here in this, the definition, stone columns are vertical inclusions of compacted gravel or crushed stone installed into the ground to improve the mechanical properties of the soil. They increase soil density, shear strength and drainage capacity. There may be mitigating liquefaction risks. So here, what are the properties involved in these stone columns? That is soil density, shear strength, drainage capacity, mitigate. So these are the things we are going to understand for getting the load bearing capacity and reduce the settling. And also the installation. The columns are typically installed using a vibratory probe that displays soil laterally as the stone is introduced and compacted layers. This process densifies the surrounding soil and forms a network of strong permeable columns that reinforce the ground. So here, stone columns are vertical inclusions of compacted gravel or crushed stone installed into the ground to improve the mechanical properties of the soil. They increase the some of the properties of the soil. Those are soil density, shear strength, drainage capacity. There may be mitigating liquefaction risks. So here the installation process. The columns are typically installed using a vibratory probe that displays soil laterally as the stone is introduced and compacted in layers. This process densifies the surrounding soil and forms a network of strong permeable columns that reinforce the ground. So this is the overview of the stone column. So for getting the desired properties of the soil for the construction, so we are going to understand these things and we are going to install the same. Now this is the solution. So stone column is the solution for this. Now design consideration. In this design consideration, column diameter and spacing, depth of columns, grid pattern, installation. So in this column diameter, the diameter of the stone columns typically ranged from 0.6 to 1 meters. In this, the design considerations, how much we are considering, it depends upon where the stone column diameter are involved and there were spaced intervals between 2 to 3 meters depending on the specific soil conditions and load requirements. The spacing was optimized to ensure effective soil improvement without excessive material cost. Here, Column diameter and spacing. The diameter of the stone column typically ranged between 0.6 to 1 meter. They were spaced at intervals of 2 to 3 meters depending on the specific soil condition. It depends upon the how much intervals and how much the typical range between is depends upon the specific soil conditions and their load requirement. The spacing was optimized to ensure effective soil improvement without excessive material cost. So the depth of columns, the stone columns were installed to the full depth of the liquefied soil layers, which extended up to 10 to 15 meters below the ground space. This ensured that the entire susceptible zones were reinforced. So this grid pattern installation, the depth of the columns. So column diameter and spacing and depth of the columns are decided depends upon the soil conditions and the load requirements and what kind of full depth installation, how what will happen. These are the parameters we are going to ensure to susceptible the zone was reinforced. Now this grid pattern installation, the stone columns were installed in a grid pattern across the site, covering the entire footprint of the industrial plant to ensure uniform soil improvement and minimize the differential settlement risks. So this grid pattern installation, it is depends upon the entire footprint of the industrial plant to ensure uniform soil improvement and minimize the differential settlement. So it depends upon the grid pattern installation. These are the design considered we are considering as per the soil conditions and their load requirements, soil conditions, load requirements and zone, earthquake zone, and for getting the differential settlement risks. And in this construction process, the first thing we are going to prepare site prepare. Next, what kind of vibratory probe installation, stone placement and compaction, quality control. These are the parameters which are going to involve. The site was first cleared and level to allow for the efficient installation of stone column. So, in the construction process, the first thing we are going to clear and level to allow the efficient installation of the stone columns. Any surface obstructions were removed and access roads were constructed for heavy machinery. And here the next one is vibratory probe installation. A vibratory probe was used to create vertical holes in the soil. The probe displaced the soil laterally as it penetrated to the ground, creating space for the stone to be introduced. So here what kind of installation we are going to use to create vertical holes in the soil. So what kind it is depends upon the requirement. So the probe displaced the soil laterally as it penetrated to the ground, creating space for the stone to be introduced. For installing the stones, it given this space. Now, stone placement and compaction. Crushed stone or gravel was fed into the holes created by the probe in the layers. The probe was retracted and rinsed and multiple times to compact the stone, so forming a dense column. So because of this process, for getting the dense column, the process was repeated until the entire column was constructed from the bottom up. In quality control, as a construction process, throughout the installation process, quality control measurements were implemented to ensure that the columns were constructed to the specified dimensions and density. Whether what are the required stone column densities are following or not, we are going to ensure by the whenever we monitoring this specified dimension and density. This includes regular testing of stone materials, monitoring of the installation process and post-construction verification of column integrity. So these are the construction process steps involved in the construction process. Once the process was done, we are going for the testing. Now stone material testing, gradation testing, compaction testing. The stone used in columns was tested for grain size distribution to ensure that it met the required specifications for effective compaction and drainage. Here, the stone, what kind of stone, for getting the stone column, what kind of stone we are used that was tested for its grain size distribution to ensure it make the required specifications for getting the effective compaction as well as the drainage system also. For drainage also, this stone material testing is important. Now move on to the compaction testing. Proctor tests were performed on the stone material to determine the optimal compaction characteristics. This ensured that the columns would be dense enough to provide the necessary reinforcement to the surrounding soil. So, because of these tests, we are understanding the how much it is dense, how much it is suitable for providing necessary reinforcement, whether it is meet the acceptable limits or not. We are understanding about using all these kind of testing. So here we are conducting this grade test for understanding the effectiveness of the compaction and the drainage. This compaction test it would be enough provide the necessary reinforcement to ensure the columns for conducting these kind of tests. Now post installation testing. So here load testing on stone column. After installation, load tests were conducted on the selected stone columns to verify their load bearing capacity. So we are using this technique, stone column ground improvement technique, for getting the desired load bearing capacity for the project requirement. It depends upon the thing. Now we are understanding, we are conducting test whether it is reaching the installation. Once we done this installation, the stone column, whether it is reached or not, for this purpose we are doing this post installation testing. So these tests involved applying a vertical load to the top of the column and measuring the resulting settlement. In this, one more test we are conducting, that is shear wave velocity testing. So non-destructive shear wave velocity testing was conducted to assess the improvement in soil stiffness and shear strength. Here, the one more other properties we are going to concentrate, that is stiffness is the one of the property, and one more is the shear strength, are the desired properties for industrial plant in those kind of loose saturated soils. So in this, around this stone column, we are going to understand whether it is improved or are there in the soil stiffness and shear stress. For this shear wave velocity test we are conducting for understanding these two soil properties around the stone columns. Higher shear wave velocities indicated successful soil densification and reinforcement. It means once we get the higher shear wave values, it indicates it is successful soil densification and reinforcement point of view. For understanding the what kind of property we are getting is depends upon the choose the test. That gives the better understanding about the soil properties. So these are the things we will do in this. Now field monitoring and verification. Now we are going to move to this field monitoring and verification. Settlement monitoring. So in this, settlement plates were installed onto the ground surface and monitor over time to measure the amount of settlement after stone column installation. So whether the settlement is desired acceptable limits or not, the continuous monitoring helps us for understanding the soil conditions and also the safety of the construction work. So any abnormal limits we are observing at the time of monitoring, for us it's some time is there, and for we are going for the remedies for withstanding the construction. We may not considering these kinds, monitoring is not there. If may not in the certain accessible limits of the settlement is not there, in such conditions the huge losses we are expecting, the huge losses we may see. So for that, reducing all these kind of effects, it may affect in any way. So we are going to reduce all these kind of effects. We are going to understand this settlements for stone column, and also this settlement monitoring is very, very important. And these results were compared to pre-installation predictions to confirm the effectiveness of the treatment. In piezometer installation, this piezometer was installed to monitor pore water pressure within the soil during and after stone column installation. A reduction in pore pressure indicated improved drainage and reduced liquefaction potential. So these are the parameters which we are going to understand in this field monitoring and the verification. So these are the things what we understand in this. Once we are getting this, consider stone column is the solution. So once not only stone column, any technique. So once we choose the technique, first we have to understand about the technique. What is the definition, how we are using. Here it is installation. Some of the techniques it's may some other kind of process is made. According to that we are going to understand. So this installation once done, we are going to the design considerations according to the requirement of the soil and the requirement of the project. According to that, based on the technique, we are going to choose these design considerations. We follow step-by-step procedure. After that, we are going to go to the construction process, and we are understanding the test. We are conducting test as per requirement of the chosen technique for ground improvement process. So after that, we are understanding. We are conducting the post and pre-test for getting the better understanding about these things, and we are going to monitoring and verification is done. Now this is the process for any kind of technique. Now outcome and environmental consideration in this effective, what is the outcome. So once we know the problem and we know the tech solution, now what is the outcome we'll get, we will understand in this slide. So here the outcome. So effective liquefaction mitigation. So increased soil density and strength. It increases the what we required. We are getting the more strength for the soil is required. So once the stone column once we done with all the tests and installation process of the stone column, what is the final outcome we get? That is the increased soil density and strength. So the installation of stone column significantly increase the density and shear strength of the soil, reducing the risk of liquefaction. So the column provides a stiff permeable matrix within the soil, allowing for the rapid dissipation of pore water pressure during the seismic effect. Whenever the seismic events are going to be done. Uniform ground improvement. The grid pattern installation of stone columns ensured uniform ground improvement across the entire site, minimizing the risk of differential settlement and ensuring a stable foundation for industrial plant. So these are the outcomes what we understand in this stone column. So here we are increasing what are the required things at the time of the seismic effect. The columns, these stone columns are provided the stiff and permeable matrix within the soil, and also the ground improvement, uniformity of that particular locality or particular site, whenever it is there where we are conducting this grid installation of stone columns, they ensured uniform ground improvement across the entire site. It may reduce the differential settlement and ensuring the stable foundation for the industrial plant. And environmental impact assessment point of view, minimal disruption to the ecosystem. So using these kind of stone columns, it may affect environmental effects are also involved. So according to these kind of solution, we choose for the geotechnical challenge. So here this minimal disruption to the ecosystem, the use of stone column is considered environmentally friendly as it involves minimal chemical use and relies on natural materials like gravel or crushed stone. This reduces the risk of soil and groundwater contamination. And sustainable ground improvement. The stone columns provides a long-term solution of liquefaction risk without the need for ongoing maintenance or additional interventions. This contributes to the sustainability of the project, reducing the need for further ground improvement works. So these are the parameters which we are going to understand in the environmental impact assessment for stone column. So here what we are get minimal distribution to the ecosystem and sustainable ground improvement. So because of the long term solution for this earthquake point of view, so it is without the need for going or maintenance, these additional interventions. So it contributes sustainability of the project, reducing the need for the further ground improvement works. So in waste management and resource efficiency, recycling materials, in some cases locally sourced or recycled stone materials are used for the columns, reducing the environmental impact associated with the extraction and transportation of new materials. So here what we understand, so outcome, what are the environmental considerations? So here effectiveness and environmental impact assessment, management, waste management and resource efficiency. So recycling materials, in some cases locally sourced or recycled stone material used for the stone column, it reduces the environmental impact associated with the extraction and transportation new materials. So because of this, it is reducing the environmental impact. It means resource efficiency is there, and also the waste management involved in this type of technique, which we consider for the ground improvement technique for these kind of industrial plant site in such type of soil conditions. In controlled site operation, the construction process were carefully managed to minimize dust, noise and vibration, reducing the impact on the surrounding environment and nearby communities. So these are the various kinds of operations we are going to involve in this environmental impact analysis. Under this particular stone columns for liquefaction mitigation at the industrial plant site in Gujarat represents a successful application of geotechnical engineering principles to address the significant seismic risks. Through careful design, testing, monitoring, the project team was able to reinforce the ground effectively, providing a stable foundation for critical infrastructure in seismically active regions. So the environmental consideration taken during the project ensured that the ground improvement was not only effective, but also sustainable and minimal disturbance to the environment. Now we understand how it is environmentally. What are the factors involved environmentally in this particular stone column project for liquefaction mitigation? So in the context of the stone column project for liquefaction mitigation at industrial plant site at Gujarat, several environmental factors were considered to assure that the ground improvement technique was both effective and environmentally responsible. So what are the various characteristics are involved in this particular environmental factors for these stone columns? So what are the various areas we are going to understand for getting the environmental factors involved in any kind of project? So we applicable for this particular case study. So we will see in this what are the various types. Here the first one is soil and groundwater impact. So minimal use of chemicals. So because stone columns technique primarily involves the use of natural stone or gravel, avoiding the need of the chemical stabilizations or additives that could potentially lead into the soil and groundwater, that reduces the risk of contaminating the local aquifers or surrounding the land. So because in some of the situations we may choose any other kind of chemicals or additives, there is a risk, they increase the risk of contaminating the local aquifers or surrounding the land. So here we are confining the stone column technique. So it's primarily involves the use of natural stone. So natural stone, it not much affect the environment, it reduces the risk, and also there is no question of contaminating the local aquifers. Or gravel only we are using. Here we have to avoid the chemical stabilizations or additives that could potentially leach into the soil and groundwater. So here minimal use of chemicals in the soil stone columns is helpful for reducing the risk of the contaminating the local aquifers are surrounding land. Now, groundwater flow and quality. Groundwater flow and quality. The installation of stone columns alter the subsurface structure, potentiality, impacting groundwater flow patterns. However, because stone columns are permeable, they can improve drainage and reduce pore water pressure, which can be beneficial in preventing waterlogging and improving soil stability. Here, the installation of stone columns alters the subsurface structure, potentially impacting the groundwater flow patterns. However, because stone columns are permeable, they can improve drainage and reduce pore water pressure, which can be beneficial in preventing waterlogging and improving soil stability. So, the groundwater flow and their quality. So, for beneficial in preventing waterlogging and also the soil stability. So, because of the installation of the stone columns. So, it alters the subsurface, the structure, potentially impacting the groundwater patterns. So, however, because the stone columns are permeable, they can improve the drainage and reduce the pore water pressure, which can be beneficial in preventing the waterlogging and improving the soil stability. So, waterlogging and preventing the stability are the parameters which we are going to understand in this stone column. So the project's impacts on groundwater quality was likely monitoring to ensure that the installation did not introduce any harmful sediments or pollutants in the groundwater system. And resource use and sustainability. So material sourcing, the environmental impact of sourcing and transporting stone for the columns was considered where possible. Locally sourced or recycled materials were used to reduce the carbon footprint associated with the transportation and to support sustainable resource management. So, the environmental impact of surrounding, sourcing, and transporting stone for the columns was considered where possible. Locally sourced or recycled materials were used to introduce carbon footprint associated with these transportation and to support sustainable resource management. The use of natural stone as opposed to synthetic materials. So it is going to opposite the synthetic materials, minimize the energy consumption and environmental degradation association with the production of construction material. In this waste management, the project likely involved the management of construction waste, including any excess or unsuitable material excavated during the installation process. Ensuring that waste materials were properly disposed of or recycled helped to minimize the environmental footprint of the project. So, in this, using the stone column, because of this, we may choose any waste material. It may helpful. Waste material may helpful for considering the stone column materials, and also we use natural products. So that's why it is going to reduce in this particular waste management point of view the resource use and sustainability. So to minimize the whenever we use the recycled material, that gives the better understanding about the things. Now, biodiversity and ecosystem effect. Site preparation and habitat disruption. So clearing and leveling the site for stone column installation could have temporarily disrupted local habitats, particularly if the area was previously vegetated or hosted wildlife. Measures were likely to taken minimize these impacts, such as the timing construction to avoid sensitive periods for local wildlife or implementing restoration effects post construction. Now, long-term habitat stability. The improved ground stability provided by the stone columns reduced the risk of soil erosion and subsidence, which could otherwise lead to habitat loss or degradation over time. By stabilizing the ground, the project helped to protect the surrounding environment from long-term ecological disturbances. So, in this, long-term Habitat stability, we are going to understand in this biodiversity and ecosystem. So clearing and leveling the site for stone column installation could have temporarily disrupted local habitats, particularly if the area was previously vegetated or hosted wildlife. Measures were likely to minimize this impact, such as timing the construction to avoid sensitive periods for local wildlife or implementing resortation efforts for after post construction. Long term habitat stability, to improve the ground stability provided by the stone column, reduce the risk of soil erosion and subsidence, which could otherwise lead to habitat loss or degradation over time. By stabilizing the ground, the project helped to protect surrounding environmental from long-term ecological disturbance. And next one is air quality and noise pollution. So these construction related emissions, whenever we are using the stone columns, involves heavy machinery. So it means it contributes so much of air pollution, so much of noise we are getting. So construction related emissions we are going to understand under these stone columns, the heavy machinery we have to use for getting the installation and other processes. So which can contribute the air pollution through the emission of the exhaust gases as carbon dioxide and particulate matter. So, in this, to mitigate this, project may have implemented best practice such as modern low emission equipment and optimizing construction schedules to reduce these times. So, dust generation during the construction work was also managed through dust separation technique like water spraying to minimize the impact on local air quality. So for this we have to take measure, otherwise it is going to impact the environmental. And in this noise pollution, whenever we are using the heavy machinery, vibrating things and everything, it giving so much of noise. So which could disturb the nearby communities as well as the wildlife. So these noise control measures such as restricting work hours and using sound barriers were likely implemented to minimize this effect. So in these stone columns, whenever we are using these at the time of installation process and other process, because of these heavy machinery under is working, it means it is going to release some emissions to the air. So definitely air pollution, air is going to be affected. For reducing what kind of measures we are taking is important parameter for these kind of environmental impact effects. In this, dust generation during construction work are also managed through dust separation techniques like water spraying to minimize the impact on the local and air quality. So here the impact is there, but on which practice we are going to reduce those effect. In this noise pollution, whenever we are doing heavy machinery we are using, so the confined hours, working hours is important for getting the better reducing these kind of noise pollutions and the disturbances to the others nearby communities and any kind of wildlife is there. For that also we are going to reduce. How we are reducing that impact is the important parameter in environmental point of view. In this, water resources management, pore water exploration and surface water management, the installation of stone column facilities the exploration of pore water from the soil, which can lead to increase the surface water runoff. If not properly managed, the project would have included measure to collect the manage this water, ensuring it did not contribute to the erosion or sedimentation in nearby water bodies. So those kind of, it may not be involve any kind of erosion like that, we have to understand. In this, effective water management also ensure that the exploration of the pore water did not lead to the uncontrolled discharge into the environment, which could otherwise result in localized flooding or water quality issues. In energy consumption and water footprint, so energy use in construction, the installation of stone columns required the use of energy intensive equipment. So here, so required the use of energy intensive equipment contributing to the project's overall carbon footprint. So efforts to reduce the energy consumption such as optimizing the installation process and using energy efficient machinery would have been important considerations. And the project likely evaluated the trade-off between the energy consumed during the construction, and the long-term benefits of reducing liquefaction risk, which ultimately protects the infrastructure and reduces the need for the future potentially more energy intensive remediation efforts. Post construction environmental monitoring, long term environmental monitoring. So, post construction monitoring would have been critical to assess any delayed environmental impacts such as changes in groundwater quality or soil condition. Regular monitoring ensures that any advisable effects are detected early and managed effectively. Environmental management plans may have included provisions for ongoing assessment of the site's ecological health, ensuring that the improved ground conditions continue to support a stable and healthy environment. These are the long-term environmental monitoring what we consider. So finally, the stone columns project for liquefaction mitigation in those kind of Gujarat incorporated several environmental factors to ensure that the technique was not only effective in stabilizing the groundwork but also minimizing its effects on the surrounding environment by carefully managing soil and groundwater interaction, optimizing the resource use, and implementing best practices in construction. The project aimed to provide a sustainable solution to critical geological challenge while safeguarding environmental quality. So here in this particular case study, what we understand is the thing. So in this stone column for liquefaction mitigation at an industrial plant foundation in Gujarat in India, in this what kind of challenges we are facing as a project. So we have to understand the soil condition, soil type, and understanding the choose of the ground improvement technique. Once we are considering all these requirements, the solution once we find that is stone column, it is a solution. Once we find the solution, after that we are going to consider all the design parameters. What are the construction process involved? What are the tests involved? How we are going to understand the various parameters? What are the outcomes which we are going to impact in this particular scenario? And also environmental parameters, how we are assessing in various categories like wastewater management, in energy point of view, and energy consumption, and what are the various how what kind of impact we are getting under various scenarios like soil and ground, how we are reducing, how we are minimizing, what kind of approach is getting the less environmental impact, and resource and use of sustainability, various material resourcing, what kind of management is involved, what kind of ecosystem we have to follow, where it is going to, we are understanding what air in water point of view, air point of view, noise point of how we are going to manage, and what are the remedies we have to there. So in for carbon footprint point of view, in long term environmental monitoring, these are all the parameters what we understand. And finally, the thing, what kind of technique we are choosing, how it affects the project, finally what kind of results is required without losing the safe and economically, and also environmental effects are less, gives the less environmental impacts are there, that gives the better results without sacrifice of the project requirements. So these are the things we have to be understand in this particular case study. We will see in our next case study what kind of different parameters are involved, what kind of soil condition we consider. For those conditions, what kind of ground improvement technique is suitable, what are the efforts, what are the different considerations, what we consider, what we understand. We will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.